Okay class, I want to talk more about the polynomial function. Last class period we talked a little bit about the standard form of a polynomial function and some information that we can gain from looking at that. But I also want to look at the factored form of a polynomial expression. So behind me to the left here is one such function. This is h of x, and it has currently 1, 2, and there are actually 2 factors here. So we actually have 4 factors, 4 linear factors of this polynomial expression. Now, knowing what the factors are helps us to look at what zeros of a function are. Now, let's recall what that means. Zeros of a function is when h of x will equal 0. So you're looking for x values that make the function equal to 0. It's like setting this equal to 0. Those give you the zeros of a function, not to be confused with the y-intercept. That's different. That occurs when x is 0. You put in 0 for each of these numbers, and you get out a very specific y. That's where it will cross the y-axis, the y-intercept. Zeros can, however, be interchangeable with the word x-intercepts. The x-intercepts is where the y value is 0, which is the zeros of your function. So when you're in factored form like this, the zeros can be found really by setting each of the linear factors equal to 0. So you'd be finding the x value that makes this piece equal to 0, the x value that makes this equal to 0, and the x value that makes this equal to 0, which then you have to think about there are actually 2 factors of those, right? So let's do that. Let's set each of our factors equal to 0. You could probably examine this one just by looking at it and go, if x were -1, -1 plus 1 would equal 0. But if you'd forgotten that just by looking at it, you could actually do the algebra, set it equal to 0, subtract the 1, you'd have x is equal to a -1. In this one, 3 times x minus 2, you would need a number multiplied by 3 that is equivalent to 2, because 2 minus 2 would be 0. So it's the same as solving this little algebra expression, 3x minus 2 equals 0. I could add 2 to both sides to get 3x equals 2, then divide by 3. Sure enough, x is 2/3, which is the same as the opposite to this number, divide by its coefficient. Well, that's pretty convenient, nice little shortcut. But again, you could always do the algebra, don't worry about shortcuts. The x plus 5 part right here, the opposite 5 would give us a -5, and a -5 plus 5 would equal 0. So our third 0 is at -5. Now remember, this is actually occurring 2 times. So we actually call this one a repeated 0. And you can tell you have repeated zeros in the factors by looking at the power on that linear factor. These all have powers of 1, so that occurs 1 time, 1 time. This one actually occurs twice. However, on the graph, you won't see it twice. You only see the 0 show up 1 time. The shape of the graph at that point was very distinct, though. The shape at this point will look like a little mini parabola that intercepts the x-axis only once. And you'll study a lot more of that when we get on to pre-calculus. But for now, our zeros are x is -5, x is 2/3, and x is -1. Well, now let's talk about the degree of this function. We have 4 linear factors, this one, and 2 of these, which means if you were to multiply out all the linear factors, you would actually have an x times another x times another x, which would give us x to the 4th power, meaning that the highest power of x would be 4. The degree then would be equal to 4. So if we see 4 linear factors, degree 4. You can actually count the x's as a shortcut. 1, 2, 3, 4. Now the possible minimums and maximums. As I was mentioning last time, you can find the possible number as 1 fewer than the degree of the function. So we would say this could have up to 3. Alright, but we would actually want to check that because we're not real comfortable yet with knowing how each linear factor or the coefficients on the standard form actually give us the mins and maxes. Again, you'll know more of that in pre-calculus, but for now we have up to 3. I would then advise you to graph this as a y1 equals this expression on your graphing calculator. You may have to change the window, alright? It might not be a standard window. Change the window, make it a little bit bigger to see where those mins and maxes might occur.